Welcome back, everybody. This is going to be our Algebra 2 Function Foundations, Lesson 3, Function Composition Homework Review, Part 2. And in the last question, we have had formulas for both our two functions, and we did compositions in this case, sometimes of compositions of the same functions, two different functions, different order, different numbers and all. So here we have two graphs, and we're going to apply this the same way. Understand in this case, when we're trying to find h of x or k of x, we're looking for the matching y value for a particular x value. Okay, and so let's take a look here. We see in this case, we begin with a h of k of neg 2. And so what we're going to do now is we're going to find k of neg 2. Now k of neg 2 is going to be when x equals neg 2. So our matching k value will be, oops, why is this? Here we go. At negative 4. So we're going to say in this case, k of neg 2 equals neg 4. And so now we take this value of neg 4 and plug into h. So h of neg 4. So h of neg 4. Okay. And so we're going to now take a look here. Neg 4, 1, 2, 3, 4. The matching y value is negative 1, neg 2, neg 3, neg 4, neg 5. Right over here. Okay, why is it red? It should be green. I thought I put green. Green. Okay, and so that'll be neg 5. So our result will be neg 5. So h of k of neg 2 is negative 5, okay? So you find one y value and plug back to find the y value for one, and that becomes the x value for the second one. Okay, so let's continue. Let's try this again. So now we begin with 0, so it goes into h, so we'll find h of 0. So h of 0 is going to be 1. That's weird. I had that as red before. H of 0 is 1. Okay, equals 1. And so that will now go into k. So I'll find k of 1. So k of 1, when x equals 1, the y value is 1, 2, 3, 4, 5. Right there. Interesting. Picked green and goes red. There you go. Okay, so k of 1 is going to be 5. So the result is going to be, okay, too close to the edge. Okay, so in this case, the k of h of 0 is going to be, the final result will be 5. All right, so we're going from right to left in this case. All right, so here, we'll continue here with h of negative 2. So h of negative 2, becomes negative 1, negative 2, down 1, down, so h of negative 2. Again, that's weird, I picked blue, but okay. Okay, and so here, h of negative 2 becomes, well, it looks like negative 2. And then goes here, it goes to h again, so h of negative 2, what we see in this case will just be negative 2. Kind of worked out that way nicely. And now we're going to try to find, in this case, k of negative 2. So now we're going to find k of negative 2. So k of negative 2, we see in this case, k of negative 2 we found to be neg 4. It's so funny, purple, and it picks blue, so. Okay, so that is equal to negative 4. We found that previously, so negative 4. And that now goes into k again, so k of negative 4. So k of negative 4, so we go to 1, 2, 3, 4, and we end up getting at, here's 0. So our answer is going to be 0. So we see in this case that we do the same exact thing, but instead of relying on computation, we're using our graph to find the answer. Okay, so now for question number 4. Here we have these these rules here. Now, what happens in this case, ladies and gentlemen, we'll see that we're going to be plugging x into our function, and so here x goes to h, so we get in this case h of x first. So h of x is equal to 2x minus 4. Because just replace. So the key thing in this case is that h of x just means 2 times something minus 4, and we're just plugging in that whatever's in parentheses into that box, if you will, that space. So really, it's 2 times something minus 4, which in this case 2x minus 4. We're going to take this entire expression and plug into g. Now, g of x is really 3x minus 5, or 3 times something minus 5. And so therefore, when we have g of 2x minus 4, that will mean 3 times 2x minus 4 minus 5. Okay, so we're plugging in the space because the rule is 3x minus 5 just really means 3 times something, 3 times box or parenthesis minus 5. And so whatever input goes into that space. So now we're going to distribute here, and we're going to get, in this case, 6x minus 12 minus 5. And combining like terms, we get 6x minus 17. And that'll be choice 1. Okay, so remember that our functions are just rules, and we're just plugging values in. And we saw that with numbers, and the rules for numbers are the same as the rules for letters. That's really the whole idea of algebra here. So, well, let's try again. Let's try another one. Okay, so number 5. Here we have f of x equals x squared plus 5. So again, f of x really means, f of x just means something squared plus 5. And g of x means something plus 4. And whatever we plug into there is what we get, though. So we begin with g of x. Therefore, g of x becomes x plus 4. Okay, now I didn't show this before. I just want to break it down now so that it maybe becomes a little bit more clear to you in how we do this. Okay, and so now we're going to take this entire thing and plug it into f. So here we get f of x plus 4. And if you remember, our rule is going to be something squared plus 5, and in this space we're going to plug in x plus 4. So now let's evaluate. Now x plus 4 squared plus 5 really means x plus 4 times x plus 4. In our previous lesson that we covered on multiplying polynomials, we'll use in this case distributive method. So x times x is x squared, x times 4 is plus 4x, 4 times x is plus 4x, and 4 times 4 is 16. And then plus 5. So we combine all our like terms, and we get x squared. 4x plus 4x is 8x, and 16 plus 5 is 21. And therefore we get x squared plus 8x plus 21, which is going to be choice 2. Okay, so we have to be very careful about how we approach these values here. Okay, so the rules for numbers are the same as the rules for letters. And understand each rule, it just means that x represents a space for plugging something in. We just must determine what goes in that space. Okay, let's continue. So we now have, in this case, question number 6. Now, this is a word problem, and so we see in this case, scientists model the intensity of the sun, I, as a function of number of hours since 6 a.m., h, using the function I of h equals 12 minus h squared over 36. Then they model temperature of soil, T, as a function of intensity using the function T of I equals the square root of 5,000 I. Which of the following is close to temperature soil at 2 p.m.? So at 2 p.m., the number of hours since 6 a.m., so 6 a.m. to 2 p.m., well, from 6 a.m. to 12 p.m. is going to be 6 hours. Then from 12 to 2 is going to be 2 more hours, so a total of 8 hours here. And so we're going to now find I of 8. Okay? And so that's going to be the intensity of the sun, which we'll use as a result later on to help us find the temperature of the soil. So the intensity of the sun is equal to 12 minus something squared over 36. And you're saying, what do you mean? Well, I of h equals 12 minus h squared over 36. So now we're going to plug in for h, 8. And so now we get, in this case, 12 minus 8 squared over 36. That's kind of strange. Okay, so well, let's see how this works out. Just don't make sure since 6 a.m. All right, so at 2 p.m. we're gonna get, because we're gonna get a negative value, and that's not gonna work out so great, especially when we have a square root. So let's take a look and see. All right, so so we're gonna have in this case 12 minus 64 over 36. And 12 minus 64 is equal to negative 52 over 36. And so that simplifies to, that equals to, I think, can divide top and bottom by 4, I guess, right? So if I want to divide the top by 4, I think I get negative 13, and the bottom by 4, I get 9. So we end up getting this. Now I'm going to check here and make sure, see if I made an error someplace. And it looks like I caught myself an error here, because it looks like it should be, in this case, not 12, but 12H. So that changes things a little bit. So I apologize for that, but that hopefully we'll be able to fix this a little real quick now. So if that's 12H, then what happens is this becomes 12 times 8 minus 8 squared. So I was like, this, and so sometimes we make mistakes, ladies and gentlemen. So yeah, you might say, well, why don't we record? Sometimes it's helpful to see, that how we go back and say, why would we make an error? Why was an error? Well, I know in this case that the square root of number cannot be negative, so it had to be an error here someplace. So I went back and checked and see, and it was really 12H. Okay, so probably some guys read the question like, wait a minute, he's got this wrong. And it went on for a little bit. No, and I apologize for that. But, sometimes it helps to just see where errors occur and then learn how to fix them, or how to recognize where errors are. Well, so 12 times 8 is 96, still 8 squared 64 over 36. And so 96 minus 64, that will give us a value of 32 over 36. Okay, and so 32 over 36, that can be simplified. I believe, again, we can divide both sides by the top and bottom by 4, so we'll get 8 over 9. Okay, so this is the I value that we get. This is I. Now, t of I, we're going to take this value here and plug it into our function t of I. So t of 8/9 is equal to the square root of 5,000i. So 5,000 times 8/9. So let's break out our calculator here. And so we're going to take the square root of 5,000 times 8/9. So let's do square root. And we'll type in 5,000 times, and I'll put in parentheses, doesn't really matter, so 8 divided by 9. Calculator would have figured out anyway, but that's okay though. And we hit enter, and we get 66.66. We're still repeating in this case, so 66 2/3, but the closest value we get for our choices will be 67. Okay, so it's about, so in this case, approximates to 66.6 with a bar, so bar, which approximates to 67. So this is kind of see how a composition of functions works out. Ladies and gentlemen, this is the end of part 2. I hope you enjoyed this. Hope it was helpful. Please give it a like, comments, and questions and feedback in the comments section below, please. And of course, look forward to seeing you in our next video, part 3. Take care and be safe.